Hi everyone, my name is Ben Busse. I'm a product lead with DreamFactory. We make an open source REST API platform. You can find us at dreamfactory.com. So in today's talk, I'm going to talk about REST enabling enterprise data in the mobile era. And I'm going to talk a lot about reusable APIs and why these are very important when you think about your software architecture and how to actually develop modern mobile apps. So I'm going to split the talk into kind of three parts. I'm going to talk about lessons learned over the years at our company. Before releasing this open source project, we've done a lot of mobile development and built a lot of APIs and used a lot of APIs and want to share some of our experiences there, kind of learning the hard way. Secondly, I want to talk about reusable APIs. What do reusable APIs mean? Why are they important? And why should you embrace them for mobile application development? And then third, I'm going to talk about how to actually use a reusable API. I'm going to talk about some tips and techniques and actually show some examples that will be useful if you're a developer or an architect of a mobile application. So to start, what makes a good REST API for mobile apps? This question. I first want to cover some of the lessons learned over the years in our own application development. So a typical enterprise mobile project is very different from, say, a simple consumer mobile application that you're developing yourself. It's different in a couple of really important ways. So first, enterprise mobile apps almost always have to connect securely to enterprise data, which is generally behind a firewall. It exists in some secure database, and it's actually hard to develop a mobile application that can easily access this without a solid REST API that is between the client-side application that you're building and where the actual data resides. The second real key difference between consumer and enterprise is that security is a huge factor with any enterprise application. And the security issue is actually very challenging in an enterprise context. How do you secure your mobile applications and the data that's sitting on the server that those mobile applications are accessing? How do you do authentication? How do you inherit existing security policies that you have in your company? What this ultimately results in is that more than half of the time with an enterprise mobile app project is actually spent on backend integration and testing. And this is essentially a bunch of server-side code and policy that a company has to implement themselves. So this approach of developing APIs for each new application project really slows you down a lot. And I'm going to talk about why that is in the next few slides. Before I get into the details of our own challenges doing this, I do want to mention that this problem of one-off API development is actually compounded substantially by mobile applications. You think about the number of web or client-server applications in an enterprise, the number of mobile applications that companies need to build is actually vastly more, because the mobile applications obviously don't have as much built-in functionality. The user experience is a lot different. And you can think of it in a sense of an enterprise mobile app. A traditional enterprise mobile app is often shattered into a number of smaller mobile applications. And in a large enterprise, we're talking literally about thousands of mobile applications across the entire organization. These mobile apps can be used by employees internally, by partners in some cases, and obviously by end users who are the enterprise's customer. So in a typical type of application development scenario, you've got this application that you need to build. You define the requirements. You understand that there's going to be some data, if it's a data-driven mobile application, which most real applications are. This application may need to connect to a bunch of different data sources and have APIs that enable communication between the application, the mobile app running on a phone or a tablet, and SQL, NoSQL in some cases, remote file storage running on a server in the cloud or on premises in some examples, or to external services, which by that I'm referring to web services or REST APIs that already exist. So the typical flow is you define your requirements, you have a server team and a client team, and you discuss the requirements and implement a bunch of APIs. And these APIs are actually tightly tied to the application itself. And this is what I refer to as a one-off API. So now you have to develop a second mobile application. Your team is tasked with that activity. it would be nice to reuse some of the APIs that you've already built, but a couple of things are challenging in doing that. The first is that application 1 is already in production, so you're not going to change the API structure if the requirements for app 2 need some additional capabilities or some different REST API requirements are there. You can't easily inherit what you've built with application 1 because it's already in production. And application 2 had requirements that you did not foresee when you built application 1. And this happens over and over. So you get this many-to-many API effect, and we kind of call this API spaghetti. Each time you build a new application, you have an application-specific set of APIs, often a completely different security framework. It may be using either home-built or using a different user management system each and every time. And you have all of these applications that you're building, and you get this tangled web of utter complexity, which just completely breaks down your ability to develop rationally. So what are the attributes of this API complexity? You have new APIs for each and every project. Your APIs are tightly linked to the specific data sources for each and every project. It's tightly linked to the backend infrastructure for each and every new project. Often when you're building applications, you're under very tight deadlines. Documentation is typically poor, not updated. You're just trying to get the code out and running successfully and tested. This approach is difficult to scale. It's not portable, and by portability we mean the ability both to easily change data sources on the back end and also to actually move the physical application between different server infrastructures, between dev, test, and production, or on premises, or in hybrid cloud, or public cloud. You just can't move these applications around easily at all. It's a very risky proposition. There are many security vulnerabilities, so you have a hodgepodge of different APIs, and you're usually using different user management constructs, different authentication schemes. You have to ensure that you're protecting against common attacks such as SQL injection and so forth. And you have different teams that are doing these things independently, so there's no consistency with being secure. It's a lot of server-side software development, and you have this time-consuming interface negotiation between client team and server team. So this is what we've found in our own development as being just an extremely difficult way to develop software. One thing to point out is this interface negotiation that tends to occur. You have a client-side team who is really tasked with the user experience of the front-end application and the requirements, which of course change over time quite dynamically with pretty much any real project. So you have this iterative cycle of ping pong between a server-side team and a client-side team. The client-side team will say, hey, we need these APIs. The API requirements will change over time. The server-side team will then respond with an implementation approach, and you have this constant communication back and forth, which is often really time-consuming and difficult to negotiate. And then you have a team that needs to test all of the integration and make sure, of course, that it's all secure. So this adds a lot of friction back and forth between two different teams. And in many cases, we found it actually prevents companies from being able to realistically deliver anything on time, and in some cases not deliver anything at all because there's just not enough resources and not enough time to do lots and lots of mobile applications within an enterprise. So to summarize, you've done all of this work, you have this tangled web, and it's taken tons of time, and unfortunately after you've done all of this work, you don't even have anything reusable to leverage in your subsequent projects. So it's really, really frustrating. One way that we've looked at some other technologies, and many companies have looked at these, I'll cover three of them quickly. I call these sort of band-aids to complexity. None of these solutions solve the root cause, which is this API madness, this one-off APIs for each new project. So there's a set of tools that help you create APIs. So these are tools that make it actually easier to generate this complexity even faster. So you have to write a raw API from scratch, and you can use tools that accelerate your ability to write these REST APIs, but you're not solving the underlying issue, which is you're developing a REST API for each and every new project. There are also API management tools, so these are not well suited for mobile application development, for transactional mobile application development. They introduce an additional proxy endpoint, and in effect they actually increase the overall complexity of this system. You're adding another layer of abstraction in between. And again, you're still writing these one-off APIs. And that is actually the root cause of complexity. And then from a security perspective, one way to try to tackle the issue of a rogue device or a rogue employee or some other issue where a mobile phone actually has access to sensitive data, mobile device management attempts to control that at the device level, but you really want to invert the problem and control the data on the server. And if you're able to do that, you actually don't need to worry about a rogue device out there because you can shut the data down at the API level on the server where you control everything. So now I'm going to talk about reusable APIs, and reusable APIs for each new project really speeds you up a lot. And the way to think about this is to invert the problem statement. So instead of building APIs that are based on application requirements in the front end, start with thinking about the data that you need to expose and expose that data in a reusable way that many applications can use over time. You can build an application that can use that API, and you actually don't need to know the application requirements a priori. It's reusable. So the way that this looks architecturally is, of course, you have the same applications that you saw in a previous diagram on the front end. You have the same data sources that you have to access on the back end, and then you have a reusable set of REST APIs that really forms essentially a platform. These REST APIs connect to securely a bunch of different data sources on the back end, and then you can write your applications that connect to and call this same set of reusable REST APIs. And there is a security layer that's built into this type of platform approach that governs the actual end user's ability to access the API in different contexts. In other words, end users have access to applications. Applications use REST APIs, and you control on the server which users can actually access which set of REST APIs at a very granular level. So with this type of architecture, it's quite different. In contrast to the previous approach we talked about, this one-off API approach, here you have reusable APIs for any new project. The goal of this is to actually, and we do this with our open source project, is to automatically generate a ready-to-use REST API. You can use it right away. It's automatically documented. And the goal there is really that you cover the vast majority of your use cases, but you also have to have the ability to customize the REST API for special cases. This lets you focus on front-end application development, and the way that it does this is because, as you saw in the previous slide, you're decoupling the client side from the server side. The API is abstracted in a way that you can literally use any client-side technology and then use any server-side technology, such as different databases, different data stores, and the API works identically regardless of which back-end and front-end technologies you're using. This means that your back-end infrastructure is completely flexible, your data sources are completely flexible, the API is automatically documented, and what this means is a lot more scalability, a lot more reliability, a lot more portability, and a reusable approach to security. So this really streamlines your application development. If you're building a single application, sure, you can build your own REST API. It's not that difficult. But if you're building a complex enterprise data-driven application and you need to build dozens, hundreds, even thousands of these applications, this is really the only approach architecturally that will work. So to summarize, reusable APIs are a good thing. They're documented, they're secure, they're portable, and there's a lot less integration and a lot less testing. So if you think about it from the timeline of a project, instead of taking 60, 70, 80% of your time doing back-end integration and testing, you can collapse that down to months of savings on a typical project, and you multiply this by many applications, and the savings in terms of your development process is profound. So I spoke a little bit about the problem statement. Now I'm going to turn to what a reusable REST API actually means. So what is a reusable REST API? So kind of speaking from first principles, if you were to design a REST API that's reusable in the first place, you would want a couple of important attributes. One would be this notion of simplicity. You want a simple API that's easy to understand, easy to use. Lots of developers can quickly grasp what it does and how it works. And of course, you also need power or flexibility. And those are often competing objectives, so you need to find a way that you actually get both benefits, simplicity and flexibility. And we'll talk about that a bit later on in the talk. We found that you really want to have a consistent structure for SQL, NoSQL, and file stores, and we'll talk a bit about why that is a little bit later in a few more slides. Your API needs to be really designed for high transaction volume, so you think about mobile use cases, particularly when you have, say, an enterprise app that's used by thousands, hundreds of thousands, or even millions of concurrent transactions happening out in the field. You need to make sure that your API is built for that type of high transaction volume. And it's more than just the API, it's the whole architecture of the platform that you're building for your API. How can it handle peak load? So that's an important consideration. Another important concept I'll point out quickly is that typically the back end, you need to not just build a native mobile application like an iOS or an Android application, but parts of the back end data you often need to expose as an actual web application. You can think of administrative functions, for example, or parts of the application may need to be accessed from a web browser internally, not just a mobile application. So you really want the API to support both native mobile and web applications. So that's an important consideration. So now I'm going to talk about reusable APIs in practice. How do you build a reusable REST API? What are the core constructs that you need to understand? And that's what we'll cover in the last part of the talk. So from a design principle, what we found to be very effective is not reinventing the wheel. Noun-based endpoints for your REST API and simple HTTP verbs work really, really well. Here I've taken a few screenshots. So this is actually live API documentation for our open source REST API, which is an Apache project. The way that this is structured is you have on the left here, this is auto-generated documentation. You have all of your HTTP verbs, and then you have a number of different endpoints, which are very simple. And this documents the API live, and the use cases are doing create, read, update, delete operations on multiple records with a lot of flexibility, but you actually need a very small number of endpoints to do that. Singleton records, where you just need a particular record and you need to operate on that particular record. And then often you will need to invoke stored procedures and or functions that exist in your SQL database, and you want to be able to invoke those stored procedures and functions directly from your client-side application. And when you're looking at this, you'll notice, well, there aren't a lot of endpoints here, and that's because it's completely parameterized. So with a good API, you're able to inspect or interrogate the database that the API needs to access and parameterize it, so you're only passing in the actual table names or the specific ID or the procedure, the function name from the application. So here, if you had 1,000 tables in a SQL database, you would be able to call each of the 1,000 tables independently, but the RESTful endpoints have the identical URI path structure. NoSQL, interestingly, is really just a subset of SQL. So you have multiple documents and single documents. And here we're looking at Amazon's DynamoDB, but it could be MongoDB or CouchDB or Cassandra or some other NoSQL store where your data resides. And here you're passing in a table name, or in NoSQL parlance that would be a collection name, also parameterized. And the only really key difference is that you don't have things like stored procedures and functions, and of course with NoSQL you don't have foreign key relationships. So some of the parameters that you actually pass in the API, which we'll talk about in the examples later, you will not have with NoSQL, but you have with SQL. So really, you think about NoSQL, it's essentially a direct subset of the API functionality that you would have calling a SQL database. The last part here, I'm going to talk quickly about file API. So here we have some endpoints that are to Amazon's S3 database where you can store files. It's a file store. And here it's also very simple. You think of accessing files. A file is essentially itself a URL, and you can access that path by going to a particular container. A container houses a set of folders, and of course a set of folders houses a set of files. And so the API is quite simple. You just go down the tree, and you can pass in some parameters at the end of your API that dictate things like whether you want to grab the full tree and so forth, and I'll talk a little bit about that later in the talk. And then often you want to upload or download a single file. That's quite common, so of course you have that capability. And once you've understood the SQL, NoSQL API, again, you have this subset effect where the file API is just a subset of NoSQL, which is a subset of SQL. So a little bit more about that, just to explain the concept. With our open source project, for example, we have 16 API endpoints to do create, read, update, delete on files, and then 35 endpoints for NoSQL. These are parameterized endpoints. And the only real difference is that you have filters that you are able to call with NoSQL. You can run queries, whereas with files, you're not running queries, you're just accessing files and folders. That's really the only difference. And then SQL is a superset of NoSQL, which is a superset of files. So SQL, you get schema, you get relations, you get procedures and functions. So it's everything that you have in NoSQL, plus these additional things that I put here in green that cover SQL-specific functionality. So those endpoints are fairly simple, easy to understand, but then how do you get the flexibility that you need to do complex queries, to do dates, to do filters, to do pagination, to do parent-child relationship joins or many-to-many relationships, and how do you get files, and then what are some advanced use cases? So that's what we're going to cover now. The way that we've approached the problem is quite simple. You just append key value pair parameters to the various endpoints. So what that looks like in practice is that each request URL has a bunch of attributes. You have a server, which is where the API is actually calling, where the data resides. You have a version number generally with an API. So here we call it /API/v2 because this is version 2 of our API. And then in this example, we're accessing an actual API name, which we're calling Oracle DB. So this is the name of a database. It's actually the name of the API. That's what we called it. And then down to the entity or the object or the table, you could call it. So here we have a contacts table. And so that is our root endpoint path. Very simple. Server, version, database, and table. And then we have a question mark where we append some parameters. And in this example, we're going to append just 2 key value pairs. We have a key called filter, and we're going to pass in a last name, which is a field, an operator, which is like, and then a string, which is the field value. In this case, it's last names that are like or start with the string JON. And then we're going to order the results by a field. And so we have a key called order, and then we're going to order it by the field called first name. And it's assumed here that this is ascending by default. If we wanted to list the results in descending order, we would add a DESC just like you would in a SQL call. So you can add as many of these parameters as you want, and what this does is it lets you operate very discreetly on any set of records that are in a SQL database, a NoSQL database. And in this example, very simple, you get back a JSON response. It could be XML, depends on what your needs are, but for mobile you tend to get JSON back, and you have an array of records with key value pairs, in this case just first name and last name. That's all we would get back from the database, but you can actually explicitly set which fields you want. That's just another parameter that you append to your request URL. So this is the paradigm by which we found it to be very simple and also very flexible to make your API calls. So now I want to cover some specific use case examples. I'm going to talk about a bunch of things. I'm first going to talk about dates, and the way I like to convey this is to just show a few screenshots. These are some applications that we've built ourselves for our customers. The first thing I want to show is just a simple date range filter. So a very common use case with any application, particularly mobile, is you want to navigate between a set of dates. Here we're looking at a calendaring application which has a bunch of tasks, pretty common type of user experience, and to navigate between months or weeks, depending on your view, you can tap an arrow which goes forward or backward, and when you do this, a dynamic API call is made. In this example, we want to find the tasks or the to-do records that occur in the month of May. So we make our API call and to that particular entity, which you saw previously, and then we append a filter, and we say very simply, filter equals the to-do date greater than May 1st, less than or equal to May 31st, and we could order the results by to-do date, and we ask for that response to come back as an ordered set of tasks from the server. You don't have to do that. You could, of course, do it on the client, but this is a very clean way to get very ordered JSON back so that the client-side application can then just draw the screen and display it to the end user. Next, I want to talk about filters. So this is really, really common. It's really universal for any data-driven application. What you want to really support in a reusable REST API, it's very important to be able to do complex filters. So in this example, this is an application that's a reporting application. It's used by project managers who are managing projects, and they need to report on who's doing what the cost attributes are of the projects, and so forth. So here in this screenshot, we want to actually generate a fairly complex filter. We want to find active projects from yesterday where the name starts with the string next. And similar to the previous screen with dates, you can do generic filters. So you can say, in this example, the filter is the create date is equal to May 3rd, archive is false, we don't want archive projects, and we want a project name to match some particular string. So what we're doing is we're rendering this API call by taking the user input from this dialog here and converting that into an API call and passing it to the server. And that's how it works. And you can toggle between unions or intersections depending on what kind of query the end user is making. So the next thing I'm going to talk about is pagination. So pagination is vital for mobile. And the reason is a lot of times you'll have a lot of records on the back end, and you can't render all of those records in the client. It kills your performance, and it's unusable anyway. You can't display thousands of records on a phone easily or on a tablet. So here there are a few key parameters that you'll want to understand. One is limits, the other is offset, and the third, again, you've seen before, this order construct. So a limit is pretty straightforward. You specify how many records you want back. Offset gives you the starting point. So in this example, literally what we're doing is loading the second 100 records sorted by name. This is a task management application where we're listing a bunch of tasks. And the way you do that is to pass in this query as a set of parameters. So really the offset is just giving you record 101 to 200 inclusive. And then again, you can order by a specific field. Here I want to order it by name, but if there was another field that I wanted to order by, I could select that. So next I want to talk about relationships. This is really important. Often you want to access like more than one table. You want to access, in this example, a project. This is a Gantt chart application. So we have a project, and of course each project has a set of related tasks, very rich user experience on the front end, and it's using simple REST and JSON to talk to the server on the back end. So we want the user to select a particular project and then load all of the related tasks. So we want that in JSON format, and then the front end application is going to use that JSON to actually render a user interface. So here, what we're doing is the API supports this idea of parent-child relationships. You pass in the API call. Here I've called my API DB API. It could be called anything. It's going to a SQL database. And then I'm going to grab the root path, which is the project, which is the top line table. And then as a parameter after the question mark, I'm going to pass in an ID. So this is going to grab ID 348, which is a project ID. And then I'm going to request a related table. So a task is related to a project by foreign key lookup. So this API just dynamically returns a project as well as all related tasks for that project as a single JSON array in a single API call. So no need to do a bunch of server-side orchestration or multiple queries. Your API should programmatically support parent-child relationships in a single API call. This is a pattern that occurs over and over again. The general cases, again, are one-to-many or many-to-many relationships. The previous one we saw was a parent-child, so one parent, many children. So the ID or the filter string for the parent ID or IDs, and then the related child table. And you can use the notion of, for example, star to get all child tables as well, which can be useful in some use cases. The other scenario is many-to-many relationships, where you have, say, an object such as contacts, let's say, and then another object called groups. So contacts can be in multiple groups, and groups, of course, contain multiple contacts, so it's a many-to-many relationship. And here you tend to implement this with a intermediate table, often called a junction table, where you hold the IDs of table C and table A, and the junction table is table B. So here, similar paradigm as before, you can grab the ID of the parent object that you want, and then I'll call it a sibling object, but it's really, in this case, the example would be go get some contacts, and then go get the groups that these contacts are associated with. So in this case, you call the groups table by name. And that, of course, in the back end is joined by a junction object in the middle. So the API should be smart enough to detect what the junction object is and go get the first object and then its sibling table via that junction table relationship. So another common case related to relationships, of course, is not just fetching the data with GET requests, but you often need to post or update or put a record in its child records, and you should be able to do that as well with a single API call. So here we have this contact ID, a singleton ID, Adam Ross, and there's a child table in the database called contact info. So these are different ways of contacting each individual by, say, home or work phone number. And our client application, say we want to update the home phone number, we can do that and then post the whole JSON array back to the server. And we can also append a parameter, which is a rollback parameter. We can say rollback equals true or false. If it's true, then if this whole insert doesn't occur with the API, the database will return an error message, and then we tell the client application, we provide an error message that it didn't actually get inserted. So here we're looking at the dependencies between different tables, and we want to make sure that all of the data gets inserted. So this is another type of parameter that you'll want to think about. So quickly, I want to cover a few more topics. I want to talk about files real quickly. The files and binary objects are pretty straightforward as far as it goes. So here we have a document management application, and it's accessing Amazon's S3 document repository. And we're going to fetch everything that exists in a particular container. So here we have /S3, which is our API name, and then the container name is applications, and then there's a root folder name called Dream Team Docs. So these parameters govern what actually happens when we make that API call. So we want to go to that path, and then we want to include all the folders, and we want to include all the files, and we want to expose the full tree. So this is effectively going to fetch everything in that container. So this is fairly simple. Once you understand NoSQL and SQL, this all becomes quite straightforward because you're just directly accessing the path of a folder or a particular file, and you can pass in these simple parameters to decide what is it that you want to actually fetch. The general cases for files, quickly, you can get all folders, subfolders, and files in a container, which we just talked about. And then getting a file and posting a file is very simple. You just need to pass in the container and the full file path based on the directory structure of the file. So lastly, I want to cover a few advanced use cases. I'm going to talk briefly about stored procedures and functions, and then I'm going to talk a bit about this idea of server-side scripts. And lastly, I'll cover the idea of enabling schema management with the REST API, which can have a lot of utility. So stored procedures, a good API for mobile applications with this type of architecture, you want to be able to access all of the powerful functionality that's native to a SQL database. So a lot of the server-side crunching can still, of course, occur on the server. And often what you'll see with enterprise mobile apps is, you've already written a bunch of stored procedures that already exist and you want to be able to inherit those. So we showed a couple cases of relatively simple API calls where you have a parent-child table, but what happens when you want to do a complex query that spans 5 tables or more even? Well, you generally would want to implement that with a stored procedure. And so you want to be able to expose the stored procedure name and then post to a query data that contains the in and out parameters that you want to pass to that stored procedure in the body of your API request. And that's what these API paths are showing with our open source product. Stored functions are really conceptually identical to stored procedures. You want to be able to call a function. You want to do a get or a post on a function name. An example of this is just the classic database trigger. So you can still use those database triggers. Say, for example, when a record gets inserted into a table, you then want your trigger to do something else. Well, you should still be able to do that with your REST API and invoke that call to occur on the database server. So all of the things that we've talked about so far were really about simple cases of calling an application or an application calling data on the server with a REST API. We have not gotten into any discussion about enabling business logic. So how do you do that with an API? So a bunch of examples exist for this. The common ones are implementing, custom business logic, workflow triggers, where you want some behavior to occur based on an event. Formula fields, for example, you want to do runtime calculations. You don't necessarily need to store the data in a database, but you want to, calculate a tax or perform some type of formula calculation. Field validation, so of course you should always do a good job of validating your input on the client, but you really also want to enforce that validation on the server, and you need to do that with some type of script methodology. And then in other cases, remote web service orchestration. So you have an API call that then invokes another API call in the server to occur, and that API call could be made anywhere. It may actually be outside of the enterprise's own database in some cases. A public API or a secure credentialed API that exists somewhere else. So these are some examples. The way that we've thought about this has been really simple and very effective in our own development is exposing these server-side scripts at each and every API endpoint in the entire API tree. What I mean by that is, I'll show a couple of examples. Here we have the API db.contacts, which is the object, and then we're going to show a post and a pre-process and a post-process on that particular API call. So an example of what we mean by pre-process is when an API call is made, when a request is made, we want to intercept that request and do something. So a classic example of that is field validation. So here we have a little JavaScript routine that occurs at runtime before we insert a contact into the database using the REST API. We want to loop through the array of records that are coming inbound in the JSON, in the API request, and we want to loop through and go ahead and throw a field validation error if some data is missing. Like if the first name is missing or the last name is empty, we will throw an error in that case. So this is a simple example of field validation that's occurring on the request side. Now, conversely, on the response side, you can also do the same thing. So after our contact is posted, let's say that we want to shoot an email to a manager or send a push notification based on some logical criteria. So here, the logical criteria is simple. We just want to send a dynamic message based on the contact's first name when the contact is inserted in the database. But of course, you could do anything such as, if an account value is greater than some number, then only send a push notification in that case to the sales manager and so forth. This is the idea of a workflow trigger. And we only want to do that post-insertion on the API response. So we get a 200 back, it was successful. Now we want to intercept that and do something. So here we're going to create a message and then we're going to push to platform.api.post. So here you see SNS, which is Amazon's push notification service, and then an API path to the topic, and then the topic name. And anyone subscribing to that topic will then dynamically get an email or a push notification if they have subscribed. So that's in a sense how workflow triggers work. And you can do this generically with any API call on both request and response. So lastly, before we wrap up, I quickly want to cover Schema. So this is how you can use an API to both operate on tables and fields. So you can update your schema, you can add tables, you can easily add or remove field names, and you can do that just with an API call. Of course, when you set all this up, you have to have permissions, so you don't want anybody to be able to update the schema. And I won't get into the details of that with this talk, but anytime you think about reusable APIs, you need to have a permissioning scheme where you have role-based access control over your end users or users who are actually developing applications. What can they and what can they not do? So there's a lot of power in having an API for schema management, but you also want to make sure that it's protected and given to the right people. So there was a lot to digest in this talk today. I hope it was useful for everyone. I think to summarize it at a very high level, if you remember one thing from this discussion, think about how to simplify your development with reusable APIs, and think about the data first and how that data should be exposed universally for not just one application, but for many, many applications. And this will save you an enormous amount of time and effort in your applications and let you focus a lot more on your customers and on your front-end user experience, which is really where you should be spending most of your time. So thank you. If you have questions, you can reach out to me anytime. My name is Ben Busse. You can reach me at benbusse@dreamfactory.com, and you can find me on Twitter. My Twitter handle is @benbusse. Thank you very much.